doing experiment 2, which lets us look at Newton's second law, force equals mass times acceleration, to try to determine how well we can verify that compared to the theory. Now what we do, we've got the air track here, we've leveled it. In fact, I'll give you a demonstration that it does not move at all, or very, very little. Very, very little movement. So it's essentially level. And what we do, we have a 50-gram hanger over here that provides the only force to the experiment. That 50 grams, you have a certain gravitational pull, so there's a certain number of newtons pulling on this very thin microfilm line here. The slider is 145 grams. We have attached now an additional 40 grams to the slider. So the total mass here is 185 grams. And we want to time the length of time it takes to go 1 meter. 1 meter is when the tab on the slider hits the styrofoam ball. We'll do this 3 times to measure the speed. We'll take the average, and then we'll add an additional weight, another 20 grams to the slider, and then we'll add another 20 grams. So we'll do this basically 9 times, 3 times with the 185 grams total, 3 times with 205 grams total, and 3 times with 225 grams. And we'll look at, in principle, the acceleration should slow down because the force is unchanging, but the mass we're trying to accelerate is increasing in 3 separate increments. So here goes the first one. 3, 2, 1, 0. Measurement, 3, 2, 1, 0. Third measurement, 3, 2, 1, 0. That was 50 grams hanging over here. I want to say it's 0.049 newtons, but I'm doing that in my head, so I better be careful. And the key here is, when this thing is swinging, it doesn't behave well. Now we're not going to change the weight of the slider. Well, we are going to change the weight of the slider. We're not going to change the weight of the hanger, so we're going to add another 20 grams to the mass of the slider. The mass of the slider now is not 185 grams, it's 205 grams. time here. 3, 2, 1, 0. Now we're going to have one more mass. This mass will get us up to a total of 205 grams on the slider, but still only 50 grams providing the force for the acceleration. Grams on the slider, 50 grams providing the force for acceleration. 3, 2, 1, 0. Grams on the hanger, providing the force, 225 grams on the slider. 3, 2, 1, 0. Measurement for this combination, 50 grams providing the force, 225 grams on the slider. 3, 2, 1, 0. I got to hit up the chairman of the department for some better lab equipment, you think?
Probably. Definitely better blower.
Blower's doing better today.
And what we can use, what I used when I was a kid, there was those kind of old school vacuum cleaner. When on one side you have a vacuum cleaner, when you put it on the other side you have.
Okay, now we've made one change. Same data will be collected, but now we have an additional 40 grams hanging over the edge. So there's more force providing the acceleration, and we're going to use the same 3 masses here on the slider. First one will be at 185 grams, the next one will be at 205, and the next will be at 225. But now we have almost twice the force. So we can expect acceleration to be almost double what we saw before. That means that we're going to make the 1 meter in almost half the time we saw before. The problem we have, we could add a large weight to the slider, but we may get to the point of where the air track cannot levitate that much mass. Okay, so here we go on the first data point. 3, 2, 1, 0. point number 3. 3, 2, 1, 0. To add additional mass to the slider. We're going to add an additional 20 grams. Slider now weighs 205 grams, not 185. We still have grams on the hanger, 205 grams on the slider, 3, 2, 1, 0. Measure with this set of weights. 3, 2, 1, 0. Now we're going to add an additional 20 grams to the slider. No change to the weight that's providing the accelerating force. So the slider now weighs 225 grams. We still have 90 grams providing the force. And we'll measure this 3 times. Grams here, 225 grams here. 3, 2, 1, 0. gram slider, 90 grams sliding the force. 3, 2, 1, 0. Let's try it again so we can hit the ball. Last data point, 90 grams here, 225 grams here, 3, 2, 1, 0. Okay, you'll find in your data sheet, you take each 3 measurements for each combination of masses and accelerator. You average those, and then you calculate the apparent acceleration, and then you do a graph as part of your conclusions that show what you believe the acceleration should have been and what the acceleration was that we measured, and analyze why do we have a difference, if we do have a difference. So thank you very much.